All right, and now we're finishing up practice test number 1. We've made it towards the end, so these will all be some of the more difficult questions on the CLT math test. So I don't want you to spend too much time practicing in here. If you haven't already practiced on practice test number 2 and practice test number 3, either if I've got the videos up here on YouTube, get to some of those rather than spending time here at the end, or log on to cltexam.com and look over the practice tests that are online there. Number 114 says, a team of researchers is designing a new Mars rover that will be powered by a hexagonal solar panel. To make the panel more compact and travel, they plan to build 6 identical panels in the shape of equilateral triangles. Once on Mars, the triangles will be connected to form a regular hexagon. So that's going to look like a hexagon is a 6-sided shape. 5, 6 sides. So a hexagon made out of 6 equilateral triangles. What do we know about an equilateral triangle? All 3 sides and all 3 angles are the same. So all 3 angles are going to be 60 degrees. Okay, so that's what we know so far.
Yes.
And continuing the reading, the researchers anticipate that the hexagon will need to have an area of exactly 24 square root of 3 feet squared in order to generate enough solar power for the rover to function properly. What will be the perimeter of each of the triangular solar panels they create? The perimeter. So we got to go from area to perimeter. And the area of the whole entire hexagon is 24 square root of 3 square feet. The area of one triangle, since there's 6 of these triangles in the hexagon, would be this divided by 6. So 24 square root of 3 divided by 6. 24 divided by 6 is just 4. So I can erase this and replace it with a 4. And now that I have the area of one triangle, we can find how they figured out the area of that, right? They use the formula area equals 1/2 of base times height to get this. And we know that, let's see, so the base goes all the way across here, and the height is from the middle down here, making a little 90-degree angle here, giving us a 30, 60, 90 little mini triangle inside of our equilateral triangle. And now that we have that, base times height, we got 4 and square root of 3. 1/2 base times height equals 4 square root of 3. And then from here, we can say, okay, I know that in this 30, 60, 90 triangle, the mini triangle, right? This little one here, I like, I'm going to take this half piece out and put it over here. And I got my 30, my 60, and my 90. I know from the reference sheet, if you pull up your reference sheet, at the bottom it says that a 30, 60, 90-degree triangle will have sides in a ratio of across from the 30, um, it'll be 1. Across from the 60-degree angle, it'll be square root of 3. And across from the 90-degree angle, it'll be 2. So we've got this ratio going on. And from here, right, our 30, 60, 90, 60, 90, oopsie, sorry, I'm running out of space. It's in that ratio of 1, square root of 3, and 2. And I know that my 30-degree side here, oopsies, my 30-degree side, this 30-degree angle across from it, this side, I know that that is half of my base. So I know half of my base is in this ratio here. And I know across from my 60-degree angle that it's my half of my base times the square root of 3. Half of my base times the square root of 3. And I know my 90-degree angle side, where my hypotenuse is, that it's half of my base times 2. Half of my base times 2, which really it's going to be the size of my base, because a half times 2, that's going to cancel out. So I can just get rid of that. It's the size of the base, because the equilateral triangle, all 3 sides on every one of those triangles is going to be the same. So now I know that my base times height of my mini triangle is going to be equal to this 4 square root of 3. So we've got, I'm going to erase a little bit over here. What will be the perimeter of each of the triangular solar panels they create? So I don't need this hexagon information anymore, because now I'm working with a triangle. So I can erase this and have some more space on the screen. And now move my notes over. Okay. So I know my area of one triangle is 4 square root of 3. And I know that's equal to half of my base, right, across from my 30-degree angle, times half of my base times the square root of 3 across from my 60-degree angle. And now I can simplify this out. 4 square root of 3 is going to stay on this side. And half times a half is a fourth. Base times base, base squared times the square root of 3. And now I can start simplifying. I can divide both sides by the square root of 3 so that I can cancel out the square root of 3 on both sides. And next, I want to get my b by itself here. So this 1/4 of b squared means the same thing as b squared over 4. So if I write it like that, b squared over 4, now it's easy to see that what I need to do to cancel out my 4 at my denominator is to multiply this side by 4. Whatever I do to this side, I have to do over here. So these 4's will cancel out. And 4 times 4 is 16 equals b squared. And square root of both sides, I know that my base is 4. And that means each side of my equilateral triangle is 4, 4, 4. So our perimeter is 4 times 3 is 12.